Hey, Daniel.
Hey, Yogesh.
Um, do you see anything on the screen?
I do. I see your slides.
The
Looks
first
good.
slide, right? Okay.
ID.
Katie, I see you there.
Welcome, everyone. I think we will wait for another minute or so before we start. I see Professor Janusz has also joined.
Certainly.
Yeah. Hey, Professor Janusz, do you want to give a quick introduction about the goals behind organizing this seminar series? And that would...
No, just go ahead. It's obvious for everyone why we are doing it. So.
Okay.
Please, go ahead.
Okay, cool. Okay, hi everyone. This is Yogesh Barve, and I have myself with me, Daniel.
Hello, everyone.
Yeah. So as pointed out in the emails that we have been getting in touch with everyone. We are organizing this AI seminar series. So every week we would start with some topic related to the AI and machine learning. And we will give a quick introduction. And in the coming weeks, we will also cover some of the hands-on activity for some of the topics in the AI. So the schedule is still evolving. We are still trying to figure out what are the things that we need to include in the coming weeks. So if you all have any other suggestions, please feel free to send us an email. And if you all also would like to participate in this, please let us know. We'll be happy to accommodate. So to start with, so this would be the outline for today's presentation. So the first thing, we will give a brief introduction about the machine learning, AI, what are the different use cases and where it has been applied and heavily used. We will talk about the taxonomy of machine learning, like what are the different categories, in which we will talk about regression, clustering, reinforcement learning. Finally, we will give a brief intro to Python. So the Python is the language of choice for this series to understand the different concepts in machine learning. And we will also give information about the GitHub repository that we'll be leveraging, and also the Jupyter Notebook and the Colab series, Google Colab infrastructure, which we'll be using for running some of these examples. So machine learning. So these are like the different applications of machine learning. We see that machine learning is getting used in different domains. So for instance, there is a handwritten writing recognition, so optical character recognition. So over here we see an example wherein we have certain human written characters, and we would like to identify or classify what those individual characters mean. So that is one of the tasks which machine learning can nicely solve. We also find a lot of use cases and application of machine learning in domains such as medical and healthcare. So for instance, we can see in this figure that we have an X-ray image which is fed to this machine learning, and the program can give an indication that with this kind of certainty that this machine image tests positive for a pneumonia kind of situation. Similarly, it is used in different kind of healthcare systems, wherein some of the complex tasks can be nicely managed by this machine learning driven algorithms. We also find applications of machine learning in our day-to-day activity. So for instance, everybody using email, we see that we have a category within the email inbox called as spam. So spam filtering is one of the classical use cases where machine learning is used to identify, based on the contents of the email, it can identify whether it's a relevant email or if it's a spam or other kinds of dangerous email that one can receive. So spam filtering is heavily leveraging machine learning. Similarly, we see a lot of personalized recommendation services. So for instance, if you go to any kind of, if you are shopping, for instance, on Amazon, then you will see that whenever you purchase certain items, you can as well see the Amazon stating something like, oh, you have purchased this, maybe these other items might be of your interest. So that's a recommendation that's given out to the end user. Similarly, with Netflix, for instance, if you watch certain category, or if you are interested in certain category, then it will lay out the different other options which you can view. So this is the personalization or the recommendation service, which is driven by this data or machine learning algorithms. So Arthur Samuel, who is a famous AI ML scientist, he coined this machine learning term and stated that machine learning is a field of study that gives computer the ability to learn without being explicitly programmed. So the key phrase over here is explicitly programmed. So let's see how the traditional programming paradigm differs from the machine learning. So over here, you can see that the way we write programs as a programmer, we have certain sets of inputs. We know what are the conditions. Based on certain conditions, we can construct our program like if else. We have certain rules that we need to follow. And we write the program and execute that program on a computer, and we can see the output from there, right? So the programmer is the one who needs to understand the different if-else scenarios and lay out the actions that are needed to perform to get the desired output. Now, this thing works, but when you expand a scenario, when you have a large number of complex applications like X-rays, identification of diseases, and so on, you have humongous amount of data. And how can we leverage this data to find out some innovative patterns from those data sets? So in that sense, we can leverage machine learning, and we can use this input data to to create our own way of automatically generating the program for us. So in machine learning, we have a set of inputs and set of outputs which we can feed to the computer, and the computer can on its own generate the relevant actions or identify patterns from the given input data set. So these are the other different applications of AI, like smart assistants. We every day use the Apple Siri, Amazon Alexa, all these smart assistant on our smartphones and other devices. The product recommendation, as in Netflix, Amazon, these all heavily leverage machine learning. Similarly, we see like the self-driving cars such as Uber, Tesla, and so on. There are also a lot of machine learning algorithms that are included within them. So this is a broader class of machine learning algorithms, which we can characterize into supervised machine learning, unsupervised machine learning, reinforcement learning. There is also a semi-supervised learning, but for today's lecture, we will just focus on these three sets of machine learning classes. So supervised machine learning. So in this machine learning paradigm, what we have is we have a data set which is labeled. We have like an input and output. So we have a labeled set of given a certain input, we know what the output would look like. And based on this input data set, we would like to train what would be the outcome given certain set of input parameters. So we would like to understand the patterns, and we would like the computer to identify these patterns for us automatically. So that's what supervised learning looks like. So as an example, we can see over here is a house price prediction. So we have an input data set which comprises of X and Y's, as you can see over here. And task that we would like the machine learning to perform is, if a residence has X square feet, we would like to predict what would be the price. So we can see on the x-axis, we have the total square feet of a house, okay? And for different house, different square feet area, we have the corresponding price that is associated with it. And this is our input data set. Now, if we want to find out what would be the price, which is y, for a given input x equals 800, then we would like to identify what that price would be. So one way to do that would be using like a curve fitting algorithm. And basically for that given corresponding x value or the input data value, we can find out the value of or the output. So this is a regression kind of machine learning technique, wherein we train our machine learning model based on the input and the output data set. So we are kind of predicting what would be a given distinct value for a given set of input parameters. Okay. So if we further increase the input data, for instance, now we not only have the size, but we also add in the lot size of a house. Then how do we, and also we have a data set for the price associated with it. Then how does that represent? So we can see that now we have this three-dimensional figure wherein we have two input features, which is x1 and x2. And on the y-axis, we have the price, which is our output label. So if we keep on increasing the input features, then we can see that the X matrix over here would have all these X1, X2, X3, and so on. And we could keep on adding different input features such as the living size, lot size, floor, and all these different input parameters. And we may want to know what would be the price given all this input sets. So that would be something which we could leverage machine learning, and we could leverage regression kind of technique to estimate what a price would be for a given input data set. Okay, so how about classification? So the classification is another supervised machine learning technique. So in classification, what we have is we have the lot size as well as the size of the house as an input, and it classifies whether it's a house or if it's a townhouse. So these becomes the labels. So the house could be characterized with a given set of size and a lot size. So we can see in this figure over here is on the x-axis, we have the size, and on the y-axis, we have the lot size. So we can see that the townhouse have a lower value of the lot size, and townhouse is shown with the orange. Whereas a house typically is characterized with higher higher amount of the lot size. And that's why you can see that there is some, these blue dots, they represent a house. So this would be our input data set. And so if the task is like, if the machine learning a prediction model is given an input, say a size and a lot size, then we would like to understand whether it's a house or a townhouse. So that kind of learning can be done by this machine learning model using the classification technique. Similarly, the classification is leveraged in image classification tasks. So in image classification task, one could have an input, which is a raw pixel of images, and the output would be what that image stands for. So for instance, over here, one can see that in the first image over here, we have raw pixels. So the image can be categorized into pixels of say 26 by 26. And what that image represent is we are labeling this particular image with the name as flamingo. Similarly, we have naming for the different kinds of images over here. Another technique, another use case for classification is figuring out what are the different objects in a given image. So over here, we can see that given this pixel image, it is the machine learning is trying to identify what are the different objects within that. So over here, we can see that there's a fox, which is identified by the machine learning. Similarly, over here, the machine learning algorithm classifies that there is an airplane. There are two airplanes within this a single image. So these are some of the classification tasks which machine learning can perform. Similarly, we have the facial detection. We have like facial detection libraries such as OpenCV and so on. And that is also, Daniel, do you want to talk about this?
Yeah, if you look at this, what this is doing is taking the image on the left, which is a bunch of faces, and if this is one of the examples included with OpenCV. There's a trained classifier that's supposed to detect faces in images, and the image on the right shows these with circles around them, so it shows what it's classified as faces. You'll note 2 false positives, so it does a pretty decent job, but 2 false positives isn't great with things that are very clearly faces. So one thing to note is it's only a handful of lines of code once you have this trained model and classifier to implement something like this. And so only a handful of lines of code more to be able to put this in a larger pipeline. And so that's one of the goals of the seminar series, is to talk about these general principles and general things. And then later on, we'll look and see how do we actually build these things up efficiently and use these libraries in smart ways.
Yeah. Okay. So just to recap, in a supervised learning, we have like a label data set, which has like input and the output features. And we can train a machine learning model to predict the output features given a set of input parameters. Next, we move on to another class of machine learning algorithms called as unsupervised learning. So in the unsupervised learning, in contrast to the supervised learning, is we don't have any output labels. So in a data set that we train for a house model, for instance, we can see that there was the input like the size and the lot size, and it could classify whether it's a townhouse or a regular house. So that was the input. We already had labels, whether it's a house or a townhouse. So the whole data set was available with us. But there are scenarios wherein we do not know the patterns. So we do not know whether it's a house or not. And we would like the machine learning or the computer itself to infer what are the different classes that are the different patterns that it can see within a given data set. So as I mentioned over here, the same example. So we have the lot size and houses, and this is in a regression kind of classification mechanism. We already have the labels, whether it's a house or a townhouse, given the size, the lot size, and the size of the house. Okay, but what if we don't have any labels, whether it's a house or a townhouse, and we would like to infer given the input data set? So this kind of scheme, such as clustering kind of algorithm, could be leveraged to find out and different kind of clusters or patterns within the given data set. So if so this is one example over here on the left hand side. We can see that the same housing price, that data set, which did not had any labels. The machine learning, something like clustering algorithms such as k-means and so on, could be leveraged to find out these patterns. And we can see that these the algorithm was able to come up or identify two patterns or two clusters over here. And if we try to see what those two clusters represent, is we could infer that the top cluster was the blue cluster, which is our house, and the orange data sets over here were corresponding to a townhouse. Another example over here is like if we have an input which has a bunch of different kinds of um, uh, like a football, soccer ball, and basketball, and so on. But we would like to identify how are they different. So we could use some of this clustering kind of algorithms to automatically figure out where they correspond. So we can see that when we train this with a clustering kind of algorithm, then the algorithm is able to infer that these form one category of images, these form another category of images, and so on. So this is the unsupervised learning, wherein we don't have labels for the output over here. So the input is just the different features, and we don't label them. And that's where we leverage unsupervised kind of learning algorithm um, to automatically figure out these different patterns. So the different use cases of clustering. So in a social network kind of analysis, or a social network system, we may be interested in identifying what are the different individuals who have similar kind of interests. So in that kind of to answer some of those questions, we could leverage like clustering kind of algorithm to figure out the different patterns among the different community within a large social network. Also, in a computing kind of clusters, as we know that there are different kinds of hardware capabilities. There could be different machines which have like GPUs and so on. But each of these machines, sometimes we might not have labels associated with it, but based on the performance of individual machines, we could kind of use clustering to infer what are the different categories of machines that are available in a server farm. Clustering is also used in market segmentation and astronomical data analysis kind of use cases. Another interesting use case of clustering is, say, there are like two speakers um, that are giving a talk, and there are like two input like a mics over here. So we have like two mics, and we would like to figure out the different so each speaker would have a different pattern or a way they speak. So we would like to identify those patterns within a unified kind of waveform or input that we are trying to grab over here. So we would like to automatically identify and separate out the voices of these two speakers. So we could leverage something like clustering to automatically identify the different segments that are associated with the individual speakers. So just to recap, in an unsupervised learning kind of algorithm, we don't have any labels. So we just have some input data set, and we would like the computer to come up and infer from the data set the different patterns that it can identify. Another class of machine learning algorithms is called as reinforcement learning algorithm. So in a reinforcement learning algorithm, we would like to train um, um, an agent to make its own decisions based on certain optimization properties that it would like to maximize. So for an instance, we have an agent such as a robot that is trying to trying to walk in a given environment, right? So we would like to find out what are the different actions that it needs to perform so that it can navigate a given terrain, for instance. So now solving this would be a very difficult problem, and we could leverage like reinforcement learning kind of algorithm, wherein the agent over here tries out different actions, and once it performs certain action, it can observe whether it has achieved certain goals or the rewards. So this loop, the agent continuously performs different kinds of actions and observes the reward that it achieves for performing a given set of actions. And based on that, it runs different trainings and multiple iterations of training to automatically perceive what are the different actions that it need to perform to navigate a given terrain, for instance. So an example over here would be like a Super Mario kind of game. So in this, if we want to come up with an agent that automatically plays the Super Mario game, right? So over here, if we the different actions that that agent can perform is like he can either jump to the right, he can navigate to the right, left, and so on, right? So these are the different actions that the agent can perform. So whenever he performs certain action, he can see what are the rewards associated with it. So the rewards would be like whether it has avoided an enemy, for instance, right? So if it has collided with an enemy, then it loses points. So the reward shrinks. So, and that's how in this reinforcement learning, the agent keeps on trying different kinds of actions and observing the reward that it achieves, and it automatically learns what are the actions that are necessary to maximize the reward. This is one of the use cases of reinforcement learning, wherein say we have two vehicles, and there is a follower vehicle that is trying to observe a vehicle that is in front of it. So the idea over here is to figure out whether it has reached too close to a given vehicle so that it doesn't collide with the forward vehicle. So to avoid that, it runs reinforcement learning kind of mechanism to train itself such that it applies or learns policy to press the brake and avoid any kind of collision. So this is one of the examples wherein reinforcement learning can be leveraged. This is another example from DeepMind AlphaGo. Daniel, do you want to quickly?
Yeah, just very prominent examples. If you're not familiar with it, there's a really interesting video from the team behind AlphaGo about how it learned to play Go at a beyond professional level and beat the world champion. The example on the right is how robots. An example of a paper that trained robots to walk via deep reinforcement learning. Really neat paper as well. So check either of those out. In the previous slide, if you haven't watched the video about using reinforcement learning to play Super Mario, it's really neat. Watch that as well. It's a fun example with computer vision and reinforcement learning.
Yeah, I think we do have one example over here. Let me see if I can play this. So to give a context, there is a robot who is trying to learn on its own how to walk a given terrain. Let me try to see. Is this thing visible, Daniel?
Yep.
Okay. So here you can see the robot is trying to perform different actions and see whether it can walk. And you can, on top, you can see the different episodes. So these episodes are basically the different trial and error runs that it performs. And so the reinforcement learning usually has a lot of training because the computer learns on its own, and for that it needs a lot of training data. So that it can build up its own history of what were the rewards associated with a given set of actions. So here you can see that the robot is trying to learn on its own. And after, so right now we have reached like 4,000 iterations. And as the number of simulation runs or the iteration increases, the policies that it builds becomes more and more improved. So if we go to the very last policy, we can see that now the model has trained on its own and it's able to walk. So that's one video which shows how the reinforcement learning is applied for this use case. So just to recap on this taxonomy, we have like supervised learning, unsupervised learning. We covered the reinforcement learning. There are also other class called as unsupervised, semi-supervised learning, which includes like autoencoders and things, which we will cover in our coming weekly seminar. So we have hosted all our information on this GitHub link, which points to this AI seminar series, and we will be leveraging Python as our programming language. So since a lot of machine learning libraries are developed in Python, so for this seminar series, we will be leveraging Python as our language of choice. The runtime IDE, there is one, so we can run some of these Python code directly in a web browser using something called as Jupyter Notebooks. So we can set up this Jupyter Notebook locally on our machines, but if we don't want to do any kind of provisioning on our own laptops and machines, then we could use something called as Google Colab, which automatically has that facility for running all these Jupyter Notebooks.
Let me, can I jump in here and share my screen, Yogesh?
Yes.
Okay. So everybody should be able to see my screen. So this is the, can you see my?
Okay.
Can you see my screen, Yogesh?
No, we see Yogesh stuff.
I think, let me stop sharing. Okay, I can see your screen now.
Okay. So this is the GitHub repo that Yogesh just mentioned. So we tried to consolidate everything into one single page, one single repo. And for the majority of the information, hopefully it's presented just on this one single front page README, so that if you're following along and you want to know where we are, what we're doing, you just have to go to one page. So we did this instead of using Box or other collaboration tools. This GitHub's free, lots of reasons. So if you look at the README, you tried to break it down into, at the top, there's a schedule, and we'll keep this up to date with what we're talking about that week. So this week is an overview. We're going to talk about Google Colab a little bit in a second, Python. There are two other things here, the Coursera topic and the hands-on ML book chapters. So in the email we sent out, we said there are a couple of primary learning sources. So we're pulling together this information from lots of sources, but there are two primary ones that people are encouraged to follow along with. We realize that it's hard, given time constraints, for everybody to follow along maybe as much as they'd like to with every source of learning material. So I realize that, and So we've tried to pick out what we think are fairly good ones. There's no one size fits all for everything, but let's just walk through the two that we have selected. So one is a Coursera course, and one is a hands-on machine learning book. Okay? And we have references to those here. It's just quick links in case you lose them. So the hands-on machine learning book, this is a link. If you have a VUNet ID login, it's available freely through the Vanderbilt website, through the O'Reilly for Higher Education. And it's called Hands-on Machine Learning with Scikit-learn, Keras, TensorFlow. So I click on that, and then you can browse through this book. You may be able to find a PDF version of this book online as well. Maybe or maybe not freely available. I'll just pull my copy up. This is what it looks like. Hands-on machine learning with scikit-learn, Keras, and TensorFlow. It's a really nice book. Chapter 1, so I referenced that over here. On the GitHub page, homework for next class. We said for a more detailed overview of ML, read chapter 1 of this book. So this reinforces the concepts in the slides that Yogesh just talked about. Gives a little bit more detail. The other primary source of material, things to follow along with if you have time, is this machine learning course on Coursera. And there are a bunch of these. There's some on edX, there's some on Coursera. So you could click on go to course. I think they just started a new session this week, 2 days ago, for you to sign up, for you to log in and access all this material. So you get an overview on the left, and then you can click through the different week's materials. And I think if you want to speed ahead, if you want to go to week 5 or week 6's material and access that before you've done, for instance, week 3's, that's an option too. But week 1 is what we'll cover, is your homework for next time. So this is kind of a more in-depth introduction to, this is just linear regression with one variable, starts out with one variable, goes over the intuition behind cost functions, gradient descent. Not much of the math, but a little bit of it. And week 2 then starts on multivariable linear regression. So for week 1, so summarize this, there are two kind of homeworks for this week for next time. So if you can't do anything else, read this first chapter of the hands-on machine learning book. If you want to do extra, go through the Coursera machine learning course. If you need a Python refresher, Yogesh is about to talk about this in more detail. We have a link to a good one here. It's a set of slides. Obviously, one set of slides is not going to make you a master in a programming language, but it'll help get you up to speed and get you started and pointed in the right direction. And you can review Jupyter Notebooks. So like Yogesh said, what we're trying to do with this is make this a practical introduction so that everybody has a certain amount of baseline knowledge and can implement machine learning techniques and things inside projects and pipelines with a minimal amount of effort using this background knowledge. Not necessarily make you linear algebra experts and reinforcement learning experts, but just make it so that you can jump on a project that's centered around machine learning or neural networks and know how to use these standard libraries, TensorFlow and PyTorch and things like that. Jupyter Notebooks are one of those things where you can install it locally. But what we've tried to do is say, if you don't want to devote the time to setting up a Python environment, or you work on different machines, you just want to be able to implement these things and prototype them quickly, Jupyter Notebooks are certainly the way to go, and Google Colab is also certainly another great way to go. So Yogesh is going to talk about these a little bit now, but this GitHub page is your kind of your one-stop shop for everything that we cover in the class. One other quick note, for each week, we'll also add a folder with the material for that week. So after this class, we'll make a folder called Week 1. And the slides and any other materials that we present for the week will be inside that. So I'll give it back to Yogesh now to
Yeah.
go over the Python and the collab.
Okay. All right. Yeah, so is this thing visible?
Yes, we see your screen.
Okay. So over here, I just wanted to give an overview of like the how does the Python and its different libraries look like. So over here we have at the center we have like a Python language. These are the different categories of different libraries. So for instance, the SciPy, NumPy, Cython, Jupyter, they all are heavily leveraged in machine learning to do matrix multiplication and those kind of mathematical algorithms and so on. So they have support for all that to do at a reasonably fast pace. Jupyter is something we will quickly look at, which allows you to directly run code snippet in a web browser and see the output of it. The next set of category over here that you see is something like Matplotlib, Seaborn, Scikit-image. These are all libraries that help in visualization of the results. So they really have a lot of different sets of visualization options that are available within these libraries. And at the outermost layer over here, we see the actual machine learning libraries. So we have like PyTorch, Scikit-learn, TensorFlow, and so on. So these are the ones that actually implement all these clustering, supervised learning. So they have the implementations to carry out these different kind of algorithms. So let me show you all the Google Colab over here. Is this thing visible still?
Yes.
Okay, nice. So Google Colab is a platform as a service kind of offering from Google Research, wherein they provide free resources for running these Jupyter notebooks. So basically on this Jupyter notebooks, you get isolated instance of a virtual machine or a container for running this Jupyter notebook. So in a Jupyter notebook, you can not only run, but you can also document your code. So this thing over here that you see is all the information when you can describe what the algorithm is, what that program stands for, and so on, right? You can also execute different code snippet. So, so if you click on this run arrow, you can actually run the Python code, the Python executable. Okay, sorry. All right. So seems like you do need to log into this Google Colab. So you would the basic requirement, you need to have Google account. But once you have that, you can run a code snippet. So over here, you are actually running a Linux command. So you can see that you are running Python version, so you can know what version it is. If you want to see what is the Linux distribution, MA, for instance, you can actually run that too. Okay, you can see that it's running Linux so and so version and so on. So It is a web browser interface to a running container, for instance. You can think of that. Here you can see that it talks about the basics of Python. This is the Jupyter Notebook, which is hosted, which is linked to the GitHub that we have over here. You can run different, so this is a function which basically prints out the quicksort. So this is, this just give a gist of Python tutorial. So you all can as well go through it after the class. You can run and execute the individual code snippets over here, right? Also, one of the good things about Jupyter Notebooks on Collaboratory over here is that you can leverage GPU instances which are available within Google. So if you don't have a GPU on your laptop, you can leverage this infrastructure freely to run some of your machine learning workloads using this Jupyter Notebook. I'll have to figure out how to execute that, but in the coming lectures, we can go through how to execute that in the GPU instance. So that basically covers this Jupyter intro. And the Python refresher. So yes, so this is the GitHub URL that we will be continuously updating it, and we'll post all our slides and all the contents that we'll be using to cover during this lecture series on this. Yeah, I think that's all I have from my side. Daniel, do you want to conclude this, or do you have?
No, it's really nice job, Yogesh. That's about it. Hopefully this is a way for us all to get on the same page together. So some people here, there are a few people on the phone who are really machine learning experts, have a lot of experience with it. So hopefully they'll be stepping in the coming weeks and giving some advanced lectures. So next time we're going to go through linear regression. So make sure to check out the Coursera homework, or if you can't do that, do the hands-on machine learning book, read through that, and we'll be going through some exercises next Wednesday. So it'll be hands-on stuff. Any questions you have, you can direct them to me or to Yogesh. We'll either add them to the GitHub repository as a dedicated page, or we might start a mailing list, or have a wiki page on the GitHub page or something. So yeah, please feel free to ask questions. I always say this in classes, but really no question is dumb, nothing at all. We're all here to do this together, and everybody's here to encourage everybody else. So please, let's make this fun for all of us.
Yeah,
and that's all I have. So
yeah, that's nicely put. Also, if anybody would like to volunteer and participate, and I think in some of the more advanced topic like reinforcement learning, we would really love if somebody could help us in crafting the lecture for that. So anybody have any questions? Or suggestions?
Wonderful job, guys. Thank you.
great, thanks.
Thank
Okay.
you. And that was very enlightening. Thank you.
Yeah, very good. Okay,
Right.
then I guess we'll talk to everybody next week.
Yeah.
All right, thanks everyone.
Thanks everyone.
Bye.
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 Thank you.